Hello, my name is Michael, blog with InnovativeTeams.NET. Excited to share a session today with you on building and deploying a LangChain app on Google Cloud Run. And today we're going to kind of feature using Google's Gemini model because it rocks. So let's get started. This session is very much sponsored by DevFest Florida. You can find us at devfestflorida.org. The Orlando conference is going to be kicking off September 28th. That's like in a few days. And so make sure to buy your ticket if you are kind of in the Central Florida area. You could also find DevFest Florida in Miami in December and also in Tampa on October 5th. Great way to build community. In Orlando, we are connecting with big brands like Google, Microsoft, Intuit, ThoughtWorks, Postman, many more. So come join the community. It's going to be a great time. Speaking of community, if you want to join us, you could also join us at GoogleDevCentralFlorida.com. That's kind of our main website where you can learn more about all the cool things we're up to. And this is kind of like our crew from DevFest Florida last year. You could also join our Discord that's pretty active. And actually, it's a good way to connect with our speakers actually right now. So check us out at GoogleDevCentralFlorida.com. For me, like many sci-fi enthusiasts and tech people, like I'm very much inspired by Star Trek. And in Star Trek Next Generation, Captain Picard is trying to get some relaxation time with his friends, and they're doing a holo novel for Sherlock Holmes, which is why they're all kind of dressed up weirdly. So they're going to get like kind of, cosplay and act out a story from the Sherlock Holmes universe. And in this case, they're meeting Moriarty, the computers acting as Sherlock Holmes' nemesis. And, so we're kind of in this neat space where the computer programs we're now writing in 2024 are somewhat acting like this. So if I want to like encounter a synthetic Ben Franklin, it's actually not that hard to write. In fact, using the ideas that I'm showing you today, you'll be able to write that program. Or you'll be able to kind of like say, who are you? This is, impersonating Spock. How do you feel today, Spock? And Spock, being the unemotional Vulcan that he is, gives me a meh answer, right? So that's kind of our demo app for the day that we're going to get running and get it running on Google Cloud Platform. I'm kind of assuming though that maybe you don't have a lot of cloud experience or, experience with Docker. So we're going to be unpacking a lot of those concepts for you today. While we're still in the land of inspiration, for me, my favorite large language model app is Conmigo. I have kids, so I'm always trying to think of out of the box ways to engage them in their learning. Khan Academy has been a thought leader in using YouTube as a platform for educational engagement. I know I go back to Khan Academy when I don't know linear algebra stuff. It's quite good. And so a lot of their research has been going into, hey, how do we use a large language model to be a good coach? So the common complaint that we hear from teachers with large language models is like, hey, so students are basically plagiarizing, like, writing their homework using large language models. Let's change the story a bit. Like if the computer could be the coach to help them along the way, and the software is designed to um, not do the work for the student, but be the coach and give them like, the baby steps to help them be successful. I think that's a really cool app. Something I appreciate as a father. In the enterprise, you can think of sort of situations like, hey, so I'm a service ticket guy. I'm trying to help a customer. We've had a history with this customer for over the past month. I don't read very fast. Wouldn't it be cool if a large language model could go through all those tickets and summarize the kind of relationship we've had with this customer very quickly? That's definitely a sweet large language model use case. In 2024 and forward, we're going to see a lot more of the turn of conversation about agentic large language model usage, where large language models are going to do more robust things like planning. So I want to go to Miami. I want to spend like X thousand dollars. I want to do these kinds of things with my family. Hey, large language model, go plan that for me using these constraints. By the way, I want you to use Expedia and I want you to use the search engine and have these tools. That's the next wave of kind of agentic innovation that we're going to see from Microsoft and Google. For me, the one that moved me for the Google use case was seeing a co-pilot act as a project manager. Very similar situation where you have a project manager who just needs a little bit of help um, balancing a bunch of divergent tasks on her project. So it's great that a co-pilot can kind of like be watching the conversations going on in the workspace, watching the documents at the same time, and can actually give certain classes of situation awareness based on all that, and actually maybe help co-plan things with the project manager. Gemini is Google's foundational model and builds upon their decades of research in deep learning. Google has been like an AI first company before it was cool. And the innovations that they brought to us first were, being able to, have a multimodal model that embraced text, images, audio, code, and supporting creative process. What makes Google like different, all the large language models succeed on summarization, content tagging, answering questions. Um, Google's models were the first to actually do image generation and image understanding. So the idea I could kind of like show a picture to Gemini and say, hey, this is all the stuff in my pantry. Can you help me find recipes that use all the stuff? Like that's software you could write. So what helps Gemini stand out over OpenAI and ChatGPT is very much some of the context window stuff. The context window for ChatGPT is actually relatively small. So with, being able to process like over, like 2 million tokens worth of data, you can put you know, a really big book into memory and find those really, really important pieces that matter. Maybe it's a long legal document and there's a particular nuanced detail you're trying to get at. Gemini is going to be good at that. Let's say it's a fairly large code base and there's a little like detail you're trying to search for. Gemini again will be very good at that. Typically, Gemini is positioned to be connected into all the things Google, your Gmail, your Google Docs, your Google Workspaces. So that is another kind of advantage that you're going to see if you value the existing Google ecosystem. Google Gemini tends to also be um, very coupled to like Google Search. So unlike ChatGPT, which its knowledge kind of falls over at a certain year point, you can actually ask Gemini to write blog posts on current events. So I can say, hey, Google Gemini, write me a blog post about all the cool things that are going to be happening in Cocoa Beach in October. And because it has that underlying Google search kind of going on, it's going to be successful there. So what tools are you going to need to build your own AI applications? So first, you're going to need a Google Cloud Platform. So make sure that you get a trial. The trials for Google Cloud Platform tend to be very generous. So make sure to get that. You're going to connect you with getting a Google Gemini API key. And if you wanted to explore local testing of the solution, you're going to want to install Docker or Docker Desktop and Docker Compose. Today, we're really going to just focus on the scenarios in Google Cloud, though. So when you get started with Google Gemini, I really encourage you to make sure to get the Gemini API key. That's your step one. You're going to ai.google.dev/aistudio. You're going to want to kind of play around with the Google AI Studio. And this is kind of like your test bed for programmatically exploring the different flavors of Gemini that are out there and what their kind of differences are. You also have a really robust prompt gallery that gives you kind of an idea of the types of solutions that you can make with the Gemini API family. The Google AI Studio has a nice little code generator. So once you got an idea of what you want to do, you can kind of pump out some of the code for you as a starter. So again, we're kind of building this Spock chat experience where we're going to impersonate Mr. Spock from Star Trek and hopefully make it fun. We're using today LangChain, which is the most popular open source framework for exploring large language model innovation. They have been the first open source framework to kind of have a large language model agnostic way to explore these innovations. So whether you're really excited about OpenAI or Anthropic or Grok or Gemini in this case, right, you can connect into all those large language models, using this framework. They have a fantastic ecosystem to also connect into a variety of RAG databases, ranging from Google Cloud Platform vector databases, and if you're kind of like in the Microsoft space, you can connect into things like Azure AI Search and such. They also provide really cool observability tools like LangSmith. So let's say you're doing your more complicated RAG sort of application. You can kind of specify some API keys and kind of see, hey, so what is the database telling me versus what is actually getting presented to the large language model. To start off this app, we're going to create a requirements.txt. The GitHub repository will be coming to you in a little bit, but for now, we're just going to, put on all our dependencies, especially all the LangChain ones and protobuf, and in our main.py, we'll have some stuff to import all of our dependencies, but at the top here, we're importing our Google API key. We don't want to put secrets into our public repository. So when you get your Google API key, you'll need to learn how to set in the environment variable for Google API key, and then you'll be able to run the script completely. Down to line 15, we're instantiating the Google generative AI model with a Gemini 1.5 Flash. And then we're kind of instantiating a really, really, really short prompt, respond as Mr. Spock from Star Trek. That is, really concise, but it does a lot. And then we plop that into our prompt template, which kind of combines the template with the incoming text. So when we generate a bot chain, and chain is just like kind of a really fancy word for a function. Let's just kind of make it simple, right? It's a function with a little bit of flavor in that, like, you can take that prompt template, pipe it into the large language model, and then pipe it into a string output parser. So that's a little bit of like the chain concept, but at the end of the day, this turns into a function. We're going to do a few more imports to import Fast API, which allows us to connect this to kind of web infrastructure. Here we're going to add the add routes, and here we're adding to the app our bot chain or function to /chain. So that feels very abstract. Let's make it more concrete. So like in any LangChain service, right, we can go to /docs. It comes with this really cool like API documentation, so you could see all the routes that actually got registered. We have like all these /chain routes got registered. The one that we really care about is this one, /chain invoke. That's the only one we're going to use today. And then we're going to say, how do you feel today? Question mark. We're going to execute that. And then we could see, as a sentient being, I do not have experience with emotions. That's a very Mr. Spock thing to say. So that totally makes sense. So again, so when we did the add this /chain to the routes, that's kind of what happened. We also registered that HTML interface to the app. Not really going to dig into that during this talk, but just know it's a very, very simple vanilla JavaScript way to interact with that API for demo purposes. Okay, let's talk about a few concepts before we move on. So Docker containers, very intimidating, but hopefully we're going to motivate it really well. So in the physical world, shipping containers facilitate a form of standardization that enable us to kind of like ship random things in a more robust way. So in another world, right, I play way too much Minecraft with my kids and do these LAN parties. And, they sometimes ask for these esoteric Minecraft servers like Scriptcraft. This is this particular server. It's kind of a pain to put it together because you have to like install this very particular versions of Java. You have to get these environment variables particularly right. There's all these like the stuff that's just, it's not fun. If you have to do it by hand, you're going to be sitting there for 2 hours, right? Wouldn't it be cool if like someone put that into like a little package, a little image, and just like, it was always done? And that's exactly what Docker containers is. It's like this fusion of virtual machines with recipes. So I could say, I want a Scriptcraft server because we're going to do Minecraft and JavaScript and exploding arrows, and it's going to be awesome. So I can just do Docker pull and the Scriptcraft thing, and that's going to pull that whole like definition of that virtual machine, that machine onto my computer. After that, I can kind of make an instance of it um, and run it. So this would be called an image. Once this thing is running, it's called a container. So those are the two big concepts there. You have images and you have containers. Containers are the thing that are actually running. Images typically are stored in what we call container registries. So Docker Hub is the largest public registry of images, and that's really good exercise for you to go and explore. But then on your client machine, you can do things like build images. You can instantiate containers and run them. So that's the whole concept framework of Docker containers and whatnot. It provides you portability and efficiency and consistency. So when I have a very tedious process to set up my non-trivial business app, I don't want to do that like non-trivial setup process on a production server, a QA server, or a staging server over and over again. I want to write the recipe really once and then have some way to configure it for these different environments. So in the Google Cloud Platform, we're now going to kind of just taste a little bit of what that feels like. So we're going to need, our Google Cloud Console. So you would go Google for Google Cloud Console, make sure you're all like kind of set up there. We're going to use Cloud Run, which allows us to kind of take a particular Docker image and fire it up, make an instance that accepts public traffic. And we're going to pull that image from a container registry. So we're just going to like explore all of those concepts today. So I'm already logged into my Google Cloud, and kind of at the top here, we have the current project that I am kind of engaged in. What I recommend is, click New Project, specify a project name. So maybe use your last name dash whatever. For now, I'm going to do Rosario dash LangChain 4, and I have that set as my current project. If you want to search for all the kind of like cool products that Google Cloud has, you can kind of use it as a search experience here. We also have access to Gemini here, right? If you want to ask questions, not going to go into that, but it's very cool. We're also going to do and activate our Cloud Shell. And this is where we're going to do a lot of like our kind of stuff today. Let me see if I have that folder there. I do not, so I'm going to try to walk this lab along with you. So in our Cloud Shell, it's kind of cool because I can also click this thing and hey, I'm back in Visual Studio. How'd that happen, right? So I can kind of like iterate going between the terminal and an editor. So let's start off by getting our kind of repository for today. Let's do some checks of how I'm authenticated. So I'm going to do gcloud list, gcloud auth list, and verify that I am who I am. And this will also make you grant authentication to this console, and that's fine. I'm going to kind of verify that we are in the project that we really care about. Gcloud space config list project. And this should be Rosario-LangChain 4. That is indeed the project I want to be kind of working today. And again, the importance of the project piece is that like after you finish this code lab, you want to be able to put all this stuff into the garbage. Or maybe in an enterprise, you want to be able to like watch the cloud costs connected by that project for accounting, right? So you want to kind of be cognizant of that. We're going to then also enable all these kind of permissions from the AI platform, resource manager, registry. I'm just going to give it all the things. I think I've already kind of done this step, but this finished successfully. And now we're going to pull down our repository for this lab. So this is pulling from GitHub, Michael P. Rosario, / LangChain cloud run lab. Okay, so it's properly cloned. I'm going to do cd LangChain, etc. Get in there. So if we do ls, we'll see that we actually have a Docker file here. Let's look at what's inside that Docker file. So this is, again, the recipe for this virtual machine where I am uh, starting with Python 3.9 Slim. I am installing all of my requirements. I'm going to expose the app on port 80, give it a name, and I'm asking it to run the Python main program. So the main is right there. So let's go ahead and um, build out this image here. Gcloud builds, submit. I'm specifying the image that I am wanting to build up on, and we're using the Docker file that's in the current directory. So this is going to take a little bit to, look around, but let's take a quick tour around the Google Cloud Platform just real fast, just to see what other cool things are going on while this is cooking. So we can see kind of like our places for billing. Again, be conscious and check in on billing often, just so you don't rack up bills on things you don't really want to pay for. Let's say we want to, we'll be using Cloud Run today. So if we click on Cloud Run, we can kind of see all the kind of like Cloud Run services that are active. Let's see if I have something else active right now. So I have a app here, and it's kind of running totally fine. So that's, how you kind of change projects. Going to go back to Rosario LangChain here. Let's see what else is kind of fun. Cloud storage and monitoring buckets is definitely like useful. Let's look also just kind of at our editor real fast down here. So if we go open the editor, we have a kind of modified experience with our good old friend Visual Studio Code. And I'm going to just kind of like take a tour again. We got the LangChain program that we've been kind of like exploring here. You can do a certain amount of like active dev just from here, just from even a good old fashioned Chromebook. That's kind of cool. If you do want to do some of these things kind of in local dev apart from the cloud, you can, I've written out like the commands you need for building the container image here, Docker space build -t, and that gives a image name on the current Docker file. You can also, you'll need to specify a Google API key for this. So a Docker compose file is kind of cool in that you can kind of in a YAML sort of way say, hey, I want to instantiate this image with this port configuration, and I'm going to specify a list of environment variables. So in this case, you would put your Google API key here. So that gives you kind of a sense of how that works. So we're running this, our bot program with a specified image and putting in the different kind of secrets that we have. Okay, so I see that my image has cooked at this point. So let's go ahead and deploy this one. So philosophically, we need to run this. So we're doing gcloud run deploy. We're specifying the image. We're also specifying our Google API key here on port 80. So at a high level, that's going to be there for you. Please know that I'm going through a lot of the CLI stuff rapidly, but I will put into show notes today, the kind of like step-by-step stuff that you need. So under service name, we're going to just say accept the default. We're going to say, please put that in service area US East 1. And yes, I want to accept public traffic. So if we did everything right, we can go back into Cloud Run and hopefully we're going to start seeing it show up. Let me make sure that this is my current project. Okay, so let's go back to Cloud Run. Yeah, so we can actually see it's running here. So if I now drill into this, yay, look at that. My little chat application is in fact running. Hello there, what is your name? Do you feel today? That's a very Spock answer. Peace and long life to you, friend. So that's our quick tutorial of getting your little Spock app into Google Cloud Platform with Cloud Run. And I hope you have a great day. Take care.